In this video, we're going to look at topic 5G, factoring with multiple methods. So these problems might have two steps to them where you actually have to factor a couple of times. The first problem we're going to do is 2x squared minus 8. So right off the bat, I always look for my GCF. That is going to be your step one, is to look for some common factor that everything can divide. And in this case, that's going to be a 2. So I can take that 2 out of both 2x squared and negative 8. And when I factor out, I'm going to be left with x squared minus 4, because we're sort of dividing by that 2. Then the next step in this problem is actually going to be to use the difference of two squares method, because I see x squared and negative 4. So sometimes it's kind of hard to decide, do I keep going? Is this done, or can I do more to it? So if you ever see an x squared, that exponent there, that means you might be able to keep factoring. So you should always sort of double check that it's actually done, or if there's something else I can do. In this case, we have two perfect squares being subtracted, so we're going to use that formula, that pattern of taking the square root of both, and we'll have x squared, or x minus 2 and x plus 2. Square root of x squared gives you the x terms, and the square root of negative 4 gives you the 2 terms. So this is going to be our final answer for this problem. Make sure that you always remember that the greatest common factor, that 2, needs to stay out front. It's not the same answer, and it would be a wrong answer if you don't keep the 2 out front. Next problem we're going to do is 14x squared plus 7x minus 21. So again, the first step, look for a GCF, and I know that 14, 7, and 21 can all divide by 7. So I'm going to pull that 7 out, and I'll be left with 2x squared plus x, just that 1x, minus 3. Now we pause and think, can I still divide this trinomial over here? Can I factor it into two smaller binomials? And I certainly hope so, so we want to check. We're going to pull the 7, keep it right there out front. And I'm going to think, if I can make two binomials here, I first need to think about the 2x squared. What can multiply to be 2x squared? I know that 2x and x is the only combination that can make 2x squared when multiplying. And then I want to sort of check, what can multiply to be the negative 3 over here? And we have the options of negative 3 and 1. We could do negative 1 and 3. And it does actually matter which parenthesis group these go in, because it will be multiplied differently depending on where it is. So when I check, I think I'm going to try a negative 3 on the right and a positive 1 on the left. And now I want to check, if I multiply these out, do I get back to that trinomial right above? So I'll have the 2x squared, distribute the 2x to the negative 3 and get a negative 6x, distribute the 1 to the x, distribute the 1 to the negative 3. So we've got the 2x squared, we've got the negative 3, and this middle term would combine to be a negative 5x, which is not the same as that positive x that we have above. So something went wrong here, and it's not just a matter of switching the signs. I think it's going to be a matter of switching the placement as well. So let's try again. I am literally going to erase these guys and try another option. So we already tried the option of negative 3 and 1, where the negative 3 was on the right. So I'm going to try positive 3 and negative 1 and switch the placements, and we'll see what happens here. So if I do the 2x times x, that's 2x squared. 2x times negative 1 is going to be negative 2x. 3 times x is positive 3x. And 3 times negative 1 gives us that negative 3. So the middle two terms that combine will add up to the positive x that we have above, which means this is right. This is our final answer. Let's try another one. Next problem on the left here is 2x squared plus 12x minus 80. So again, is there a GCF? That's my step 1. I think they can all divide by 2. So I'm going to pull out the 2, divide every term by that 2, and keep it just sitting out front. Step 2 is going to be to think, can I keep factoring? Since I have an x squared term, I might be able to keep factoring. And since there's no number in front of our x squared, this is going to be one of those problems where we just have to think, what can multiply to be negative 40 and add to be positive 6? So I need to think to myself, what multiplies to be negative 40, adds to be positive 6? Well, I'm thinking, what multiplies to be negative 40? I've got 1 and 40. I've got 2 and 20. 3, no. 4 and 10. That might be what we need, because that way those can actually subtract to be a positive 6, depending on which one is positive and which one is negative. So I want to do x plus 10 and x minus 4. That way when these multiply, they become the negative 40, and when they add, they'll become that positive 6. So this is going to be our final answer. With the 2 out front, that GCF is super important. 2 times the quantity of x plus 10 times the quantity of x minus 4. Last problem we're going to do over here. Same couple of steps. We first see if there's a GCF. And in this case, it's actually not just a number, it's a variable as well. It's going to be 2x. And then when I factor out 2x, I'm left with a 1, don't forget the 1, minus y squared. And this sort of looks like it should just be a GCF problem, except I have y squared and I have another perfect square there. So our next step is to actually think I can factor this using our difference of squares method like we did in the first problem. Square root of 1 is just 1. Square root of y squared is going to be y. So we get 1 plus y and 1 minus y. And that is it.